Good morning.
Hello, good morning.
You probably seen your surroundings, but I'm back home. Now I'm California in San Francisco, and we will continue our online lectures. Can you hear me and see me well?
Yeah.
Yes. Excellent. I will again check your attendance, but before I will do that, I have some comment. Because actually many times during our regular classes face-to-face, I also talked about not being an employee of Wiley Plus. I do not work for Wiley Plus customer service. And because of that, dear ladies and gentlemen, definitely it is your right to send me your complaints about some technical difficulties related to Wiley Plus, but unfortunately, I will not be able to help you. As I mentioned that many times before, I can mention this again. It can be a problem with your computer. It can be a problem with your browser. It can be a problem with Wiley Plus product. Please contact customer service and tell them about all your problems. Maybe they can help you. If they cannot, because actually if I'm receiving that kind of complaints about not working product from one or two people, and actually lately just I think on late Friday or I don't remember the exact day, or Saturday, I received complaint only from one person that no, she was not able to actually work with Wiley Plus. It means that something is wrong with maybe your browser or your computer in general. In this case, definitely, you can share with me, you can send me your concerns, but I will not be able to help you. If I have also any kind of problems, I also reach customer service and tell them what I'm experiencing, what I'm going through, and they sometimes are able to help me. Sometimes I need to do that using other type of help. Thank you very much for understanding. What would be our topic for today and the section number? It is from your textbook, section 8.3. It starts on page number 342, and I can even show to you. This is polar coordinates. This is actually, I can say, an application of trigonometry, but this is a new material unless you already took a pre-calc class before. Can you please write this topic? And this is again, polar coordinates, section 8.3 in your textbook. I would say a few words right now about this polar coordinate, and after that I will check today's attendance because I can see that not, no, definitely I can expect that not everyone will be here, but we are missing some people. Okay. What can I show to you right now? This is your regular the Cartesian rectangular coordinate system. And this is the point P, which in that the Cartesian rectangular coordinate system has coordinates A and B. How do we do that? From that point, I build perpendiculars to reach x-axis, and another perpendicular is to y-axis, y-axis and x-axis. And first coordinate is so-called x-coordinate. Second number in this pair is y-coordinate. And together is a pair of coordinates. If it is three-dimensional space, we also deal with that space as three-dimensional also. There will be also the Cartesian three-dimensional rectangular coordinate system. In this case, each point will be having a trio of coordinates, let's say A, comma, B, comma, and C, comma. But we are talking about flat system. It is two-dimensional. But if you can look at this coordinates right now, you can see here additional information which I'm showing right here. This additional information comes in terms of r and theta. What about these two symbols? You can see r represents a distance from the origin of the Cartesian system to that point P. And theta is the angle which I showed here in positive direction from positive part of x-axis to that r. In other words, if we just try to pay attention to that r and theta, look what I have here. Now, you do not see traditional here x-axis and y-axis. You just can see positive part of x-axis with the origin, and you see that r and theta right here. This how polar system looks, because here I just need to know two pieces of information. I need to know that r value, which is the distance from point P to that pole. Instead of saying that it is the origin, we call it a pole of that system. And this angle, corresponding angle theta for that point P. In this case, I can say that my point P will have another pair of coordinates, and these coordinates are r and theta. And this new coordinate system has a different name. It is a polar system of coordinates. Again, what do you see here? Here, A and B, which are, okay, I can write this in that form as well, as you understand. On the top of that P, I wrote P has a pair X and Y. I just, in this case, can put emphasis that that A is the X coordinate and B is the Y coordinate. Or it can have coordinates r, comma, theta. Again, the first is the Cartesian coordinate system. The second is polar coordinate system. So far, so good?
Yes.
Yes.
So I would like to right now, let's say, get connection between both coordinate systems. And I'm going to write the formulas. You can find these formulas on page number 342. And you can find actually these formulas at any textbook in which they talk about polar coordinates. What about these formulas? First, how to express the Cartesian coordinates, or we can say rectangular coordinates, through polar coordinates. For this case, you can easily use very easy formulas involving trigonometry. And I'm going to box it and I will show it to you right now. And again, you can find these formulas on page 342 in your textbook. This is the connection. This how can you find X and Y coordinates if you know polar coordinates of any point. And you can easily get that from this triangle, which you see right here. This is that triangle, because what I'm showing here is a point which belongs to the second quadrant. Let me actually write down even this measure of that angle in that triangle. Can you see what I wrote? 180 degrees minus theta. Can I?
Yes.
And this is a right triangle, which has one right angle, two acute angles, and you can easily, using easy trigonometry in the right triangle, you can get this relationship, which I just boxed. Again, x equals r times cosine theta, y equals r sine theta. But not all the time we need to convert polar coordinates into the Cartesian coordinates. We have other type of problems in which the Cartesian coordinates are provided and we need to get polar coordinates of given point. So what should we do in this case? Do we have formulas? Yes, we have. And I'm going to write it down right now. This is the formula for R, because in that small right triangle in which I showed a right angle and acute angle measure, R plays a role of hypotenuse. So practically we can easily get this relationship using Pythagorean theorem. Tangent theta. Tangent theta equals to the ratio, definitely, if x is not equal to 0, we can build that ratio, y over x. If we know tangent of theta and we know the location, I'm talking about a corresponding quadrant, definitely we can find angle theta measure using methods which we used a lot, solving easy looking trigonometric equations. Because again, if tangent theta equal to that ratio y to x, we can get this, if we know x coordinate value and y coordinate value, we can divide them by each other and we will get the value for tangent theta. And after that, tangent theta equal to the certain number, it is a trigonometric equation with respect to theta, and we can find it. If x is equal to 0, in this case, it can be without building that tangent, we can conclude that theta should be, or let's say, pi over 2 or 90 degrees, or 3 pi over 2 or multiples of these vertical quadrantal angles. And now I'm going to box that also, which means here in two boxes, we have two different type of formulas, but in both formulas, we are connecting the Cartesian coordinates and polar coordinates. Are you with me?
Yes.
Yes.
Do you have questions?
No.
So far, so good?
Yes.
Did you have an opportunity to sketch both systems?
I did. Yes.
Yeah, because this is quite important to make everything visual. And I'm going to solve problems actually with you right now. So the exercises, just one second. The exercises for this section are starting on page number 347. And I will assign you right now some problems. And definitely I will join your company after I check attendance. And let's say, excuse me, this is the spot from problem number 1 to problem number 9. You can randomly choose any of these problems. And here we have quite easy request. In exercises 1 through 9, in which quadrant is the point with the polar coordinate theta? So theta here is a part of that polar pair representing polar coordinates for each of these points. So theta is a corresponding angle for that point P, let's say, if we call it point P. So please do that work and let me tell you about these problems. Let me grab a piece of paper and I will write. So page number 347, problems number 2, 4, and 8, please. Okay, let me grab my calculator as well, just one second. And please start solving these problems and I will be with you very, very soon. Okay. Today is 27th. Andrew, Tima, Lorraine,
Here.
Lynn,
Here.
saw your name, okay. Juanita,
Here.
Yuran,
Here.
Gabriel,
Here.
Divina,
Here.
Kobe, Chantal,
Here.
Gongxi,
Here.
Kyle,
Here.
Matthew,
Here.
Julian,
Here.
Nathan,
Here.
Alejandro.
Here.
Thank you very much, ladies and gentlemen. And let's actually solve these problems. Okay. What do we have in problem number theta is negative 290 degrees. What is the location for that point P? Do you understand that in this case you need to move clockwise because it is a negative theta? Can you please reply to my questions when I have questions?
Is it the second quadrant?
Because as you know, to create positive angles in the coordinate system, we move counterclockwise, right? If we are building negative numbers, we are moving clockwise. So if we are going down, we are starting from 0, we are reaching negative 90 degrees, negative 180 degrees, negative 270 degrees. For positive, it will, the movement, it will be 90 degrees. For negative angle, it will be actually a negative 270 degrees. What about that point? What is the location? Which quadrant?
First.
I could not hear, I really apologize.
The first quadrant?
Definitely, it is the first quadrant. Location is the first quadrant. Okay, questions about problem number 2? Can we move to problem number 4?
Yes.
Okay, what do we have in number 4? Theta equals 2.4 of pi. Okay. Let's talk. Is it a positive angle?
Yes.
Yeah.
Is it given in radians this time?
Yes. Mm-hmm.
Excellent. Okay, what about 2.4 as a number? Can I say that it is actually 2 plus 0.4 of pi?
Yes.
Excellent. In this case, can I write that 2.4 of pi is 2 pi plus 0.4 of pi?
Yes.
Yeah.
This is what I wrote down. Yes?
Mm-hmm.
So which means I need to move in counterclockwise direction, and I need to come back to that point which I started with, because this is 1 revolution, right? I'm talking about 2 pi so far.
Yeah.
But I'm not stopping because I am moving more up. Now, we have a unit trigonometric circle. I sketched really ugly one, really. So which means I am starting from 0 level and I'm moving right here. You can see that I'm not stopping. And how far I need to move up. If I look at the point which is 90 degrees, is it pi over 2?
Yes.
Yes.
From the other hand, can I write that 90 degrees equals to 0.5 times pi?
Mm-hmm.
Yeah.
If I compare 0.5 of pi and 0.4 of pi, which one is smaller?
0.4.
Definitely 0.4 is smaller than 0.5. Does it mean that I will not reach that level, which says 0.5 of pi?
Yes.
Does it mean that actually I am staying in the first quadrant?
Yes.
That's it. It means P belongs to first quadrant. Don't think that all the time these points will belong to the first quadrant. It is just coincident. I'm trying to find better way to show. Do you understand what I said? Because again, you are moving more up and you are stopping at some point right here, definitely on the circle. I'm just showing that theta. Do you understand why I put the dot there? It is like a stop for the theta. Not, let me actually do the arrow instead of that. So stopping right there. Can I, with your permission, move to another problem?
Yes.
Yes.
Yes, please.
Okay, the next one which I told you to work with is number 8. Number 8. What do we have? Okay, negative again. Definitely with degrees, it is a little bit easier to work with. So theta this time equals negative 13.4 of pi. If you like to make it more visual, you actually can sketch this. Let's talk about that. First of all, again, if I were you, I would separate the integer part of pi's from the decimal part of pi's. Okay? Can we write that this time it will be negative 13 pi, right?
Yes.
Minus 0.4 of pi. To make it more visual, can I write, looking at negative 13 pi, this actually is a negative multiple of pi, and this is a negative but odd multiple of pi. I like to break this into pieces. Can I say that it is negative 12 pi minus 1 pi
Yes.
and minus 0.4 of pi?
Yeah.
What do you think? Why did I separate these two pieces, breaking this into negative 12 pi and minus pi, instead of just dealing with negative 13 pi?
Because 12 pi is like it's like 6 revolutions. And pi is half.
Absolutely beautiful answer, because we definitely can say that negative 12 pi here represent 6 full revolutions into negative direction, right?
Yes.
So, which means you started with 0 level and you moved down and came back 6 times, right? I'm talking just about negative 12 pi so far. But you did not stop. You moved one more time down, reaching that level horizontal, right?
Yes.
Which is already negative 13 pi, but you are not stopping. And we again already discussed that actually 0.5, which means now that point P will belong to which actually quadrant?
The second quadrant.
Absolutely correct. It will be a second quadrant. Do you understand what we do?
Yes.
Questions? You know what? I did not assign this problem to you, but I think it is quite interesting. I'm talking about problem number 9, that I would like to ask your opinion. Would you like to work with problem number 9? Because it looks like slightly different than what we already discussed.
Yes, please.
Guys, do I have just Lorraine in my class? I really like to see other people replies as well. Again, because we, as you remember, all our face-to-face lectures were in the form of open discussion, and I prefer to keep the same actually type of our work. So what do we have right now? Theta is equal to negative 7. How should I proceed in this case? You saw in this problem theta equal to -7. Did it have any small symbol of degree?
No.
No.
No. Which means what? It means that this theta equals to -7 radians. Did you hear me? It is -7 radians. This why it is a little bit, let's say, difficult for me to realize what it is actually, how it looks, and what is equivalent of that, let's say, in degree. Look what I'm going to do. I'm going to convert this, approximating definitely, into degrees. It means, and I below in parentheses, I will write that it is -7 radians. If it has no symbol of degree, it is radians. In this case, it will be -7 multiplied by 57 degrees, because 1 radian in degrees equivalent is 57 degrees. I am going to remind you about 1 radian angle. 1 radian angle is the central angle in the trigonometric circle for which length of the radius is equal to the length of the corresponding arc for that particular angle. And you can easily, on this side, I will actually prove that it is approximately 57 degrees, even though you learned that. I don't know if you remember that or not, but I'm going to do that right here on this paper on the side. First of all, let's assume that we are dealing with unit trigonometric circle, just to make it easier. So R is equal to 1. What is equivalent of that full revolution? Let's say in radians. Is it 2 pi radians?
Yes.
Okay. What is equivalent in degrees?
360.
This is what I wrote. 2 pi, up to you to write radians, I just did it to remind you, equals to 360 degrees. And I really like to know the length, or excuse me, the measure of 1 radian angle. Can I treat 2 pi equal to 360 as regular equality? Can we divide both sides by 2?
Yes.
Yes.
Okay. Pi radians equal to 180 degrees, correct?
Yes.
Mm-hmm.
And now, actually, that part on the left, which is pi radians, I will treat like number pi multiplied by 1 radian, because we know pi actually is a number which represents the ratio of what? Circumference to diameter of any circle. And here in parentheses, I will write that pi is approximately 3.14. This is very rough approximation, but we use it a lot. You can see I wrote approximately equal to 3.14. How can I find right now 1 radian from that equality? Can we divide both sides by pi?
Yeah.
So it is 180 degrees divided by pi. Grab your calculator, please. I'm grabbing mine. And please divide 180 by pi, which you have in your calculator. So it will be, turn this on, 180 divided, second button, that angle button. So this, oh my God. Can you see anything, guys?
Yeah.
Yes.
Okay, push enter. Can you see what you got?
I got
Mm-hmm.
the same number.
This is what I'm saying. Is it approximately 57 degrees?
Yeah.
Yes.
So I was not kidding. as you understand. So now multiply in your problem. This was like additional explanation. Multiply in your, on your paper, you had -7 times 57 degrees. Please multiply 57 times 7. Okay, it is actually -399 degrees, right?
Yes.
Yes.
In this case, can I say that it is -360? Do you understand why I separated 360?
Yes.
Is it -39 degrees?
Yes.
Excellent. And now, -360, is it one complete negative revolution?
Yes.
So, and I came back to that horizontal position, right? On the right side from 0. Should I move down additionally by should I move down by 39 degrees?
Yes.
Yes.
So in this case, can you come to the certain conclusion about location of that P point?
It's going to be on the 4th quadrant.
Definitely, I already wrote it down. It belongs to the 4th quadrant. Questions about what we just discussed?
No.
Is it clear and transparent?
Mm-hmm.
So
Yeah.
I showed you a few examples here in which I showed when theta is equal to certain angle in degrees, positive or negative, doesn't matter, it's the same type of work, in radians, and when it looked a little bit strange when it was equal just to the certain number. But yeah, I showed you this example with -7, but it can be equal to any positive number as well. But the strategy will be absolutely the same as I showed for this example. Can I please move to another spot with your permission?
Yes, please.
Yes.
The next spot is quite small. They are from number 10 to number 13. In exercises 10 through 13, mark the point on the XY plane in which range from 0 degrees to 90 degrees, from 90 degrees to 180, from 180 to 270, from 270 to 360 is, one second please, is its polar coordinate theta. Okay, I can grab any problem. And honestly, here we can solve these problems even much easier. Are you okay, let's say, with problem number 12?
Yes, that's fine.
Okay, number 12. What is the point here? Point here is 2, -3. 2, -3. What do we have here? Is it x coordinate positive while y coordinate is negative?
Yes.
So in which quadrant we have this type of situation where x coordinate is positive and y coordinate is negative? Is it the 4th quadrant?
Yes.
So P belongs to the 4th quadrant. Now, what about that range? We talked about quadrants. What about borders of that quadrant? Is it from 270 to 360?
Yes.
Okay, so it belongs to that interval if we are writing this in form of interval. So this is the range. P belongs to that declared interval right now, 270, 360 degrees. I think you understand that this actually problems, like we like to say, just piece of cake. Can I say so?
Yes.
just analyzing in which quadrants we have x positive, y positive, x negative, y positive, etc. You can easily come to that type of conclusion. Do you understand how to solve these problems?
Yeah.
Mm-hmm.
Now, I'm going to offer you something slightly more challenging. And this is a spot from 14 to 18. Are you okay that I'm moving to the next spot?
Yes.
Convert the Cartesian coordinates. In some textbooks, you can see convert the rectangular coordinates. In problems 14 through 18 to polar coordinates. And we have here quite many points. How many? 5, not too many. Which problems you like to work with, guys? Choose your problem. I do
16.
not mind. What do you think about number 16? Does it look
Yes.
okay to you?
Yes.
Yeah.
You probably understand why I choose number 16, because it has an attractive x and y coordinates from your point of view. Okay, so again, it is problem number 16. Let me copy that on my paper. So what kind of coordinates do we have? Point P here has x coordinate equal to square root of 6. Y coordinate is square root of 2. X coordinate is square root of 6. Y coordinate is negative square root of 2. What I'm going to do, I will first think about location of that point. And this is, probably you would agree with me, is fourth quadrant.
Yes.
So P belongs to the fourth quadrant. Now, these are x value and y value for my P. Can you see below I wrote in parentheses x, comma, y.
Mm-hmm.
Why? Because now I'm starting the process. The first coordinate in polar system, which I like to find, is r. R, if you like to repeat the formula, it is up to you. But okay, let me actually repeat the formula for R. So it will be, you can look at these charts, which you had here in parentheses. It will be x squared plus y squared under the square root, which means it will be square root of 6 squared, because it is the first problem. So this is why I'm taking longer way to solve, showing more details. Square root of 6 squared, is it just 6?
Yes.
Negative square root of 2 squared, is it just 2?
Yes.
What do we have? We have square root of 8. But I really do not recommend you to leave it like that. 8 is not the perfect square, but is it 4 times 2?
Yes.
What about square root of 4? Is it 2?
Mm-hmm.
So voila, this is your value of R. It is 2 square root of 2. I found first polar coordinate, which is R. Now in my next move, I need to find theta. How? I am going to use the formula for tangent of theta, also which you have in that box. My x coordinate is not 0, and that's why I don't have any problems actually using that ratio which you had in this box. Tangent theta equals to y over x. y over x. Y is negative square root of 2. X is square root of 6. So it will be negative because it is negative divided by positive. Square root of 2 on the top. I will treat square root of 6 like square root of 2 times 3. This y, it lets me break this into that pieces. It is absolutely legal. And this y, I am getting, I will cancel that square root of root. I am getting negative 1 over square root of 3. And if you like to get rid of irrationality in denominator, this is what you will be getting. Can I move further?
Yes.
Yes.
So far, what we have tangent theta equals negative square root of 3 over 3. At the same time, I know that my theta belongs to the fourth quadrant. So basically, I need to solve that very easy trigonometric equation for which tangent theta is equal to negative square root of 3 over 3. And I know the location for that theta. It is the fourth quadrant. Is it true that in the fourth quadrant, tangent is negative?
Yes.
So
Yes.
which means it makes sense. So please tell me about this theta. 1 second, please. I am going to sketch small circle to make it visual. I really apologize. It will be quite ugly. I'm not using any device. Oh my God, it really looks ugly. So I know that it is in the fourth quadrant. So this is what I am showing. So, and this is, let's say, point P. Can I say that this theta equals to 2 pi minus that acute angle?
Yes.
And this acute angle is our actually reference angle. So which means I'm asking you that question. Which angle, I'm talking about main angle, has tangent equal to positive square root of 3 over 3?
Pi over 6.
Pi over 6, and look what I wrote. Theta equals 2 pi minus pi over 6. Subtract, and you are getting 2 pi, which is 12 pi over 6, minus 1 pi over 6. It will be 11 pi over 6. And this is that second missing polar coordinates. Right now, I'm going to write the final information. So point P has the following polar coordinates: 2 square root of 2, which is the R value, and 11 pi over 6. And here in parentheses below, actually I'm writing that it is R and theta. Two square root of 2 comma 11 pi over 6. And I'm done. This is my answer because they asked me about polar coordinates of the point which originally was given by the Cartesian rectangular coordinates. Was it clear?
Yes.
Yeah.
So you actually can use these solved examples to go over, definitely. And I, again, as I did before, I will continue this tradition. I will try to post this video on YouTube. And tomorrow I definitely will continue solving more interesting problems, how to convert equations which we are used to in the Cartesian form, like parabolas or other curves, into polar form, and they will look absolutely different. Try not to miss tomorrow's class. With your permission, can I end my today's meeting?
Yes.
Yes.
Don't forget, I will post another homework with this material on Wiley Plus. Have a nice, beautiful day, ladies and gentlemen. Goodbye.
Bye. Have a nice
Bye.
day.
Thank you very much. Thank you.